What if tomorrow morning archaeologists made a discovery that would rewrite everything we thought we knew about human history? Picture this scenario. Deep beneath layers of ancient sediment, researchers uncover unmistakable evidence of an advanced civilization that thrived nearly 500,000 years ago. Tools that show sophisticated craftsmanship, structures that demonstrate complex engineering, and perhaps most shocking of all, clear signs of organized society. From a time when we believed only primitive hunter-gatherers roamed the earth. This isn't science fiction. This is a genuine possibility that scientists are beginning to take seriously. And today, we're going to explore what such discovery would mean for our understanding of intelligence, civilization, and our place in the grand timeline of Earth's history. But before we dive into the implications of finding such ancient evidence, we need to understand just how revolutionary this discovery would be. Everything we think we know about human development follows a neat progression. Simple stone tools led to agriculture, which led to cities, which eventually led to the complex societies we see today. This timeline stretches back only about 10,000 years for organized civilization as we know it. Now imagine pushing that timeline back not by thousands, but by hundreds of thousands of years. We're talking about a civilization that would have existed when massive ice sheets covered much of the northern hemisphere, when woolly mammoths roamed vast grasslands, and when our own ancestors were just beginning to show signs of the intelligence that would eventually define our species. The very idea challenges our most fundamental assumptions about progress, intelligence, and what it means to be advanced. Yet the more we learn about the deep past, the more we realize how much we simply don't know. Think about this for a moment. The entire span of recorded human history, from the first written words to the present day, covers roughly 5,000 years. That's an impressive stretch of time from our perspective, but in geological terms, it's barely a blink. If we compressed Earth's entire history into a single year, all of human civilization would occupy less than the final minute of December 31st. So when we talk about a civilization existing 450,000 years ago, we're venturing into a realm of time that our minds struggle to comprehend. This period falls into what scientists call deep prehistory, a vast expanse of time where evidence becomes increasingly scarce, and our knowledge relies on scattered fragments of bone, stone, and ash. During this era, the world looked fundamentally different from today. Vast ice sheets stretched across continents, locking away enormous amounts of water and exposing land that now lies beneath the ocean. Sea levels were dramatically lower, creating coastal plains and land bridges that have long since vanished. The climate was harsher, more unstable, with dramatic shifts between ice ages and warmer periods occurring over tens of thousands of years. Yet this was not an empty world. We know from fossil evidence that early human species were alive during this time. Homo heidelbergensis, considered by many researchers to be a common ancestor of both modern humans and Neanderthals, inhabited parts of Africa and Europe. These weren't primitive creatures struggling merely to survive. They had brains nearly as large as ours, crafted sophisticated tools, controlled fire, and likely possessed some form of language. Archaeological evidence shows They were capable hunters who worked together to bring down large animals. They created hearths for cooking and warmth, shaped stone tools with remarkable precision, and even buried their dead, suggesting emotional complexity and possibly spiritual beliefs. They were, by any reasonable measure, intelligent beings capable of abstract thought and social organization. But here's where the story becomes truly intriguing. What if some groups of these early humans took additional steps that we haven't yet discovered? What if they developed forms of knowledge, technology, and social organization that went far beyond what we typically associate with prehistoric life? This isn't about imagining skyscrapers or smartphones in the distant past. When we talk about an advanced civilization from this era, we need to expand our definition of what advancement means. A truly advanced society from 450,000 years ago might have mastered complex woodworking, developed sophisticated understanding of animal behavior, created intricate systems of communication, or organized themselves in ways that allowed them to thrive for millennia. They might have built structures from materials that don't survive the passage of time. Wood, plant fibers, animal hides, and clay that wasn't fired into permanent ceramics would all decompose completely over such vast time spans. They could have developed technologies based on organic materials, created forms of art and expression that left no lasting trace, or established trade networks and social systems of remarkable complexity. The challenge lies in recognizing that our picture of the prehistoric world is built almost entirely on what happens to survive, not on what actually existed. Stone tools endure because stone is durable. Bones occasionally fossilize under very specific conditions. Traces of fire can persist as charcoal deposits. But these survivors represent only a tiny fraction of the full richness of ancient life. Consider what would remain of our own civilization if it vanished tomorrow and 500,000 years passed. Our greatest cities would crumble and be reclaimed by nature within centuries. Our most impressive monuments would weather away over millennia. Even materials we consider permanent, like steel and concrete, would eventually corrode and break down. After such an enormous span of time, what traces would remain? Perhaps some unusual chemical signatures in soil layers, scattered deposits of metals in concentrations that don't occur naturally, or subtle changes in the geological record that hint at large-scale human activity. But the recognizable outlines of our civilization would be gone, leaving future archaeologists to puzzle over ambiguous clues and wonder what kind of society could have produced such faint anomalies. This perspective helps us understand why the discovery of a 450,000-year-old civilization would be so extraordinary and simultaneously so difficult to prove. The Earth is incredibly efficient at erasing evidence of past life. Natural forces constantly reshape the landscape, bury artifacts under layers of sediment, and break down even the most durable materials. Glaciers have repeatedly advanced and retreated across vast portions of the continents, grinding everything in their path to powder and carrying debris thousands of miles from its origin. Rivers change course over time, washing away entire valleys and depositing their contents in distant locations. Volcanic eruptions bury landscapes under meters of ash and lava. Earthquakes shatter structures, and tectonic activity can swallow entire regions. Even the ocean, which might seem like a preserving environment, is actually one of the most destructive forces when it comes to human artifacts. Salt water rapidly corrodes metals, wood rots within years, and the constant movement of currents scatters and breaks down materials. Rising and falling sea levels have repeatedly flooded and exposed coastal areas where ancient peoples might have lived. Yet despite all these challenges, the possibility remains tantalizingly real. Scientists are beginning to develop new techniques for detecting the subtle signatures that ancient civilizations might have left behind. Rather than looking for obvious artifacts like tools or buildings, researchers are searching for chemical anomalies, unusual isotope ratios, and patterns in sediment layers that might indicate large-scale human activity. Some of these signals could include concentrations of metals that don't match natural geological processes, layers of charcoal and ash that suggest widespread burning, or chemical changes in soil that indicate agriculture or other land modification. Even more intriguingly, advanced societies might have left behind isotopic signatures from energy use or industrial processes that could persist for hundreds of thousands of years. The search for such evidence requires a completely different approach from traditional archaeology. Instead of excavating individual sites, researchers must examine geological formations, ice cores, and deep ocean sediments for patterns that span vast regions and time periods. It's detective work on a planetary scale, looking for whispers of activity in the very rocks beneath our feet. What makes this quest even more fascinating is that we're not just searching for any ancient civilization. We're looking for evidence of intelligence that might have taken a completely different path from our own development. This hypothetical society would have faced challenges we can barely imagine, living through ice ages that lasted tens of thousands of years, adapting to dramatic climate shifts, and surviving in a world populated by megafauna that dwarfed anything alive today. Their solutions to survival and organization might have been utterly unlike anything in our experience. They might have developed sustainable technologies that left minimal environmental impact, created social structures based on entirely different principles, or achieved levels of harmony with their environment that we're only beginning to understand. The implications of such a discovery would extend far beyond archaeology and history. It would fundamentally challenge our assumptions about progress, intelligence, and the uniqueness of human achievement. We might discover that the capacity for complex civilization has emerged multiple times throughout Earth's history, suggesting that intelligence and organization are not unique accidents, but recurring experiments in the story of life on our planet. This discovery would force us to reconsider what we mean when we talk about human exceptionalism. If another species or early human group achieved sophisticated organization hundreds of thousands of years before us, it suggests that intelligence capable of building complex societies might be far more common than we've assumed. We might not be the first experiment in consciousness and culture, but rather the latest in a long series of attempts by life itself to organize, create, and understand. But let's dig deeper into what finding such evidence would actually look like in practice. The discovery wouldn't happen overnight with a single dramatic excavation. Instead, it would likely emerge through a gradual accumulation of anomalies that don't quite fit our current understanding of the prehistoric world. Imagine geologists studying sediment cores from the ocean floor and noticing unusual spikes in certain metals that appear in layers corresponding to 450,000 years ago. Or climate researchers analyzing ice cores and finding chemical signatures that suggest large-scale burning or land modification during periods when we thought only small bands of hunters existed. Perhaps paleontologists examining fossil records would notice sudden changes in animal populations or extinction patterns that coincide with other anomalous evidence. These individual pieces might seem insignificant on their own, but together they could paint a picture of coordinated human activity on a scale we never imagined possible for that time period. The scientific community would initially approach such findings with extreme skepticism, and rightfully so. Extraordinary claims require extraordinary evidence, and the burden of proof for such a revolutionary discovery would be enormous. Researchers would need to rule out every possible natural explanation before considering artificial causes. Volcanic activity can create unusual metal concentrations. Massive wildfires can leave carbon signatures in geological layers. Climate variations can cause sudden ecological changes. The challenge would be distinguishing between natural phenomena and the subtle traces of intelligent activity across such vast spans of time. But suppose the evidence continued to accumulate. Multiple independent research teams using different methodologies might start finding consistent patterns. Chemical signatures that correlate across different geographical regions. Isotope ratios that can only be explained by controlled processes. Geological formations that show signs of deliberate modification. The moment of recognition might come when researchers realize they're not looking at random anomalies, but at a coherent pattern of evidence pointing to organized, large-scale human activity. The scientific debate that would follow would be unlike anything in modern academic history. Consider the implications for our understanding of human development. Currently, we trace the rise of complex civilization through a series of revolutionary steps. The control of fire, the development of agriculture, the founding of permanent settlements, the invention of writing, the emergence of specialized crafts and social roles. Each of these milestones represents a fundamental shift in how humans organized themselves and interacted with their environment. Finding evidence of advanced organization from 450,000 years ago would suggest that this progression might not be linear or inevitable. It would raise the possibility that complex societies have risen and fallen multiple times throughout human prehistory, each leaving only the faintest traces for us to discover. This wouldn't necessarily mean that ancient peoples possessed our level of technology. They might have achieved advancement through completely different pathways. Instead of metallurgy and mechanization, they might have developed sophisticated biological technologies, mastering plant breeding and animal domestication in ways we're only beginning to understand. They could have created complex social technologies, developing systems of governance, trade, and cultural transmission that allowed large populations to coordinate effectively without the written records we consider essential. Their mathematics and science might have been encoded in oral traditions, architectural proportions, or symbolic systems that seemed primitive to us, but actually contained profound insights. The discovery would also raise profound questions about why such civilizations disappeared. What forces could be powerful enough to erase not just the people themselves, but virtually all traces of their existence? The answer might lie in the same natural forces that continue to reshape our planet today, but operating on time scales that dwarf human experience. Ice ages don't just freeze the landscape temporarily. They fundamentally restructure entire continents, grinding down mountain ranges and redirecting river systems. A civilization that flourished during a warm period might have been completely obliterated when glaciers advanced, with their settlements buried under kilometers of ice and their territories scraped clean by moving frozen masses. Alternatively, dramatic climate shifts might have made their territories uninhabitable, forcing populations to migrate to regions where their cultural knowledge couldn't be maintained. Without writing systems to preserve information across generations, even sophisticated technologies and social structures could vanish within a few centuries of disruption. Volcanic catastrophes offer another possibility. Massive eruptions can affect global climate for years or decades, creating conditions that no civilization could survive intact. The Toba supervolcano eruption that occurred roughly 70,000 years ago may have reduced the entire human population to just a few thousand individuals. Earlier catastrophes of similar magnitude could have wiped out entire civilizations without leaving obvious evidence of their existence. Sea level changes present yet another mechanism for erasure. During ice ages, enormous amounts of water become locked in glaciers, causing ocean levels to drop by hundreds of feet. Coastal plains that might have supported large populations become exposed, only to be submerged again when the ice melts. Any settlements in these areas would now lie beneath hundreds of meters of ocean water, buried under millennia of marine sediments. The psychological impact of such a discovery on modern humanity would be immense. We've constructed our entire sense of historical progress around the idea that we represent the pinnacle of human achievement. Our technologies, our global communication networks, our scientific understanding all seem to mark us as fundamentally different from our ancestors. Learning that sophisticated civilizations might have risen and vanished long before us would humble that perspective dramatically. It would remind us that our own achievements, impressive as they seem to us, might not be permanent or unique. The same forces that erased previous civilizations continue to operate today, and our own society's long-term survival is far from guaranteed. Yet this humbling might also be liberating. If intelligence and organization have emerged multiple times throughout Earth's history, it suggests that these qualities are deeply embedded in the potential of life itself. We might not be alone in the universe in our capacity for wonder, creativity, and the drive to understand our place in the cosmos. The discovery would also revolutionize our approach to archaeology and historical research. Instead of focusing primarily on sites and artifacts from the last few thousand years, scientists would need to develop entirely new methods for detecting traces of human activity across geological timescales. This might involve sophisticated chemical analysis of rock formations, computer modeling of how different materials degrade over hundreds of thousands of years, and interdisciplinary collaboration between archaeologists, geologists, climatologists, and other specialists. The tools and techniques developed for this research could have applications far beyond archaeology, potentially helping us understand everything from climate change to the search for life on other planets. Perhaps most intriguingly, the search for ancient civilizations might teach us new ways to think about sustainability and long-term survival. A society that thrived for tens of thousands of years would necessarily have developed approaches to resource use and environmental management that we might learn from today. Their technologies might have been designed for durability and harmony with natural cycles rather than rapid growth and consumption. Their social structures might have prioritized stability and adaptation over expansion and competition. Understanding how they organize themselves could provide insights relevant to our own species' long-term prospects. The quest to find evidence of such ancient civilizations is already beginning to reshape how we think about the deep past. Rather than viewing prehistory as a simple progression from primitive to advanced, we're starting to recognize it as a complex landscape of experimentation, achievement, and loss. This shift in perspective opens doors to questions we've never seriously considered before. What if the story of human development isn't a single ascending line, but rather a series of peaks and valleys, with civilizations rising to remarkable heights, only to vanish so completely that we mistake their absence for evidence they never existed at all? The implications ripple outward in every direction. Consider the technologies such a civilization might have developed. Living in a world dominated by ice and harsh climate swings, they would have needed to become masters of adaptation. Their innovations might have focused on harnessing natural forces rather than dominating them. They could have developed sophisticated methods of weather prediction, understanding atmospheric patterns in ways that allowed them to survive climate shifts that would devastate less organized societies. Their architecture might have been entirely organic, using living trees shaped over decades into complex structures, or working with ice itself as a building material during the coldest periods. These approaches would leave no trace for modern archaeologists to find, yet they might have supported communities of remarkable sophistication. Imagine their understanding of biology and ecology. Surviving in a world filled with megafauna would require intimate knowledge of animal behavior, migration patterns, and ecosystem relationships. They might have developed forms of biological technology that seem impossible to us today, perhaps even influencing the evolution of species around them through careful management and selective breeding practices. Their social technologies could have been equally advanced. Managing large populations without modern communication requires sophisticated systems of governance and cultural transmission. They might have developed mathematical concepts encoded in rituals, architectural proportions that contained astronomical knowledge, or social structures that automatically adapted to changing environmental conditions. The more we consider these possibilities, the more we realize that our definition of advancement might be far too narrow. We measure progress by our ability to manipulate materials and energy, but these ancient peoples might have achieved mastery over time itself, creating institutions and knowledge systems designed to persist across millennia, rather than generating rapid change. Their approach to knowledge preservation presents particularly fascinating questions. Without writing as we know it, they would have needed to encode essential information in forms that could survive cultural disruption. This might have included complex oral traditions, but also architectural features, landscape modifications, or even genetic information embedded in domesticated species. Some researchers suggest that certain mathematical relationships found in later civilizations, like the golden ratio or specific astronomical alignments, might represent fragments of much older knowledge systems. These concepts appear in cultures around the world with no apparent connection to each other, raising the possibility that they descend from a common source lost in deep time. The evidence we would need to prove such a civilization existed would be subtle, but potentially detectable. Modern analytical techniques can identify human influence in ways that would have been impossible just decades ago. Chemical signatures in ice cores can reveal ancient atmospheric changes. Isotope analysis can distinguish between natural mineral deposits and those altered by human activity. Genetic studies of both humans and other species might reveal patterns consistent with large-scale prehistoric management. But perhaps the most intriguing evidence would come from the Earth itself. Large-scale human activity inevitably changes landscapes in ways that persist long after the people themselves are gone. Ancient quarries leave scars that remain visible for hundreds of thousands of years. Modifications to river channels can influence drainage patterns across vast regions. Even the selective harvesting of certain species can alter evolutionary pressures in ways that shape entire ecosystems. The challenge lies in distinguishing these subtle human signatures from the countless natural processes that also reshape the planet. Volcanic activity creates mineral concentrations. Meteor impacts leave chemical anomalies. Climate variations drive species extinctions and evolutionary changes. Separating artificial patterns from natural ones requires extraordinary care and multiple lines of evidence. Yet, the search is already beginning to yield intriguing results. Geologists studying mineral deposits occasionally encounter formations that seem oddly regular or concentrated in ways that natural processes struggle to explain. Paleontologists sometimes find extinction patterns that don't match known climate events or other natural catastrophes. Marine archaeologists mapping submerged landscapes discover features that might represent ancient modifications now hidden beneath rising seas. None of these findings alone constitutes proof, but together they create a picture of the deep past that's far more complex than we previously imagined. The Earth's geological record is filled with anomalies and mysteries that we've traditionally explained through natural processes, simply because we couldn't conceive of alternatives. The discovery of such an ancient civilization would also force us to reconsider the relationship between intelligence and survival. Our own civilization has achieved remarkable technological capabilities in just a few thousand years, but it remains to be seen whether we can maintain this trajectory over the much longer time scales that define geological history. A civilization that persisted for tens or hundreds of thousands of years would necessarily have solved problems we're still struggling with. They would have achieved sustainable relationships with their environment, developed social structures capable of surviving dramatic changes, and created knowledge systems that could preserve essential information across countless generations. Their disappearance, rather than representing failure, might actually demonstrate a form of success we don't yet understand. Perhaps they recognized when their time was ending and deliberately chose to fade away, rather than resist changes they couldn't control. Perhaps they evolved beyond the need for material civilization entirely, or migrated to regions we haven't yet learned to search. The implications extend beyond Earth as well. If intelligence has emerged multiple times in our planet's history, it suggests that consciousness and civilization might be more common phenomena than we currently believe. This has profound implications for our search for life elsewhere in the universe and our understanding of our place within the cosmic story. As we develop better techniques for detecting ancient civilizations, we might discover that Earth has been home to intelligence far longer than we imagined. Each discovery would add new chapters to the story of consciousness on our planet, revealing a deep history of minds, wondering about their place in the universe, just as we wonder today. The quest to uncover these lost civilizations represents more than just historical curiosity. It's a journey toward understanding the full potential and limitations of intelligence itself. What heights can conscious beings reach? What challenges inevitably lead to decline? What knowledge can persist across the vast spans of time that separate one age of intelligence from another? These questions take on urgent relevance as our own civilization faces challenges that will determine its long-term survival. Climate change, resource depletion, and social instability threaten the foundations of modern life. Understanding how previous civilizations navigated similar crises might provide crucial insights for our own future. The search also reminds us that the present moment, impressive as it seems to us, represents just one brief experiment in the long laboratory of Earth's history. Our technologies, our social structures, our ways of understanding the world are not inevitable endpoints of progress, but rather temporary solutions to permanent challenges. This perspective encourages both humility and wonder. Humility because it reminds us that our achievements, remarkable as they are, might not be unique or permanent. Wonder because it suggests that the story of intelligence on Earth is far richer and more complex than we've ever imagined. Perhaps most importantly, the possibility of ancient civilizations changes how we think about legacy and meaning. If previous intelligent societies have risen and vanished, leaving only the faintest traces, what does this tell us about the significance of our own efforts? Are we building monuments to ourselves, or contributing to a much longer conversation between conscious minds separated by vast expanses of time? The answer might be that both are true. Our immediate achievements matter for their effects on our own lives and those of our contemporaries. But they might also represent contributions to a dialogue that spans geological ages, each civilization adding its voice to an ongoing exploration of what it means to be aware, creative, and questioning in a universe that seems indifferent to consciousness. This realization transforms the search for ancient civilizations from an academic exercise into something approaching a spiritual quest. We're not just looking for evidence of past peoples, but for connections across time itself. We're seeking to understand whether consciousness represents a recurring miracle in Earth's history, appearing again and again in different forms, each time bringing new perspectives to eternal questions. The evidence we seek might be subtle, scattered across continents and buried beneath layers of sediment accumulated over hundreds of millennia. But the implications of finding it would reshape our understanding of intelligence, time, and our place in the grand sweep of planetary history. In this light, every anomaly in the geological record becomes worth investigating. Every unusual pattern in ancient climate data deserves careful analysis. Every mystery in the archaeological record might hold clues to chapters of human history we never suspected existed. The civilization we're searching for might have been unlike anything we can easily imagine. They might have achieved forms of advancement that seem impossible to us, or pursued paths of development that we've never considered. They might have faced the same fundamental challenges that confront all intelligent beings attempting to build lasting societies in an ever-changing world. Finding evidence of their existence would prove that the experiment of consciousness and civilization has been attempted before, with results we're only beginning to understand. It would suggest that intelligence represents not an accident, but a recurring theme in the story of life itself, appearing whenever conditions allow and contributing its own unique perspective to the ongoing mystery of existence. As we venture deeper into this extraordinary possibility, we begin to understand that discovering such a civilization would fundamentally alter our relationship with time itself. The very concept of deep time becomes personal rather than abstract. When we consider that conscious beings like ourselves might have gazed at the same stars, wondered about the same mysteries, and grappled with the same existential questions hundreds of thousands of years before our own species even existed. This temporal connection raises profound questions about the nature of progress and knowledge. We tend to think of scientific understanding as cumulative, with each generation building upon the discoveries of those who came before. But what if entire libraries of knowledge have been lost? What if sophisticated understandings of mathematics, astronomy, or natural philosophy have been developed and then erased multiple times throughout Earth's history? The implications become even more staggering when we consider what such a discovery might reveal about the cyclical nature of intelligence on our planet. Perhaps consciousness doesn't emerge once and then persist indefinitely. Perhaps it appears, flourishes for a time, and then recedes, only to emerge again in new forms when conditions become favorable. This pattern might explain some of the puzzling gaps in our understanding of human development. Why did certain innovations appear simultaneously in widely separated cultures? Why do we find similar architectural principles, mathematical concepts, and symbolic systems emerging independently across the globe? These parallels might not represent independent discoveries, but rather the rediscovery of knowledge that once existed in a more complete form. The search for evidence of such ancient intelligence forces us to develop entirely new methodologies for understanding the past. Traditional archaeology focuses on the last few thousand years, when preservation conditions were relatively favorable and human populations were large enough to leave abundant traces. But detecting civilization from deep time requires us to think like detectives investigating a crime scene that's been disturbed by hundreds of thousands of years of natural processes. Researchers are beginning to explore techniques borrowed from other sciences. Geochemistry might reveal artificial concentrations of elements that don't occur naturally. Paleoecology could identify sudden changes in plant and animal populations that suggest large-scale human management of landscapes. Even genetics might hold clues, as selective breeding of plants and animals leaves distinctive signatures that persist long after the people who created them have vanished. The ocean presents particularly intriguing possibilities for such research. During ice ages, sea levels dropped dramatically, exposing vast coastal plains that are now submerged. These drowned landscapes might hold the key to understanding prehistoric civilization. Advanced sonar mapping and underwater archaeology could potentially reveal structures, settlements, or landscape modifications that have been preserved beneath layers of marine sediment. But perhaps the most revolutionary aspect of this search lies in how it changes our understanding of human potential itself. We've grown accustomed to thinking of our ancestors as progressively more primitive the further back we look. This assumption shapes everything from our archaeological interpretations to our fundamental beliefs about human nature and capability. Discovering evidence of sophisticated ancient civilization would shatter this linear progression. It would suggest that human intelligence has always been essentially what it is today, capable of remarkable achievements regardless of the technological context in which it operates. The difference between us and our ancient predecessors might not be cognitive ability, but simply the accumulated knowledge and tools that each generation passes to the next. This realization would have profound implications for how we view modern challenges. If previous civilizations developed sustainable relationships with their environments, created stable social structures, and maintained knowledge systems across vast spans of time, then our current struggles with these same issues take on new meaning. We might not be pioneering entirely new territory, but rather rediscovering solutions that have been found before. The environmental implications alone would be transformative. A civilization that thrived for tens of thousands of years would necessarily have achieved something we're desperately seeking today: long-term sustainability. Their technologies would have been designed to work with natural cycles rather than against them. Their social structures would have prioritized stability and adaptation over rapid growth and consumption. Understanding their approaches might provide crucial insights for our own civilization's long-term survival. How did they manage resources across multiple climate cycles? How did they maintain social cohesion during periods of environmental stress? How did they preserve essential knowledge through disruptions that would have challenged any society? The answers to these questions might be encoded in the very landscape around us. Ancient irrigation systems could still influence groundwater flow patterns. Prehistoric forest management might have shaped the genetic diversity of modern plant communities. Even the distribution of certain species might reflect management decisions made hundreds of thousands of years ago. But the discovery would also raise uncomfortable questions about our own trajectory. If sophisticated civilizations have risen and fallen before us, what does this suggest about the permanence of our own achievements? Are we building something truly lasting, or simply adding another layer to a cycle that has repeated many times before? The psychological impact of such revelations would be immense. Our entire cultural narrative is built around the idea of human progress, the notion that we're climbing an ever-ascending ladder of achievement and understanding. Learning that we might not be the first to reach sophisticated levels of organization would require a fundamental reimagining of our place in history. Yet, this humbling might also be profoundly liberating. If consciousness and civilization represent recurring themes in Earth's history rather than unique accidents, it suggests that intelligence itself is a fundamental feature of our planet's development. We might not be alone in our capacity for wonder, creativity, and the drive to understand our place in the cosmos. The search for ancient civilizations also opens fascinating possibilities for understanding the relationship between intelligence and survival. Our own rapid technological development has occurred over just a few centuries, raising questions about whether such rapid change is sustainable over geological timescales. A civilization that persisted for hundreds of thousands of years would have had to solve problems we're still grappling with. They would have needed to balance innovation with stability, managing the disruptive potential of new technologies while maintaining social cohesion across countless generations. They would have had to develop decision-making processes capable of considering consequences over timescales that exceed any individual lifetime. They would have needed to create institutions and knowledge systems designed to persist through changes we can barely imagine. Their eventual disappearance might not represent failure, but rather a form of success we don't yet understand. Perhaps they recognized when their time was ending and chose to fade gracefully, rather than resist changes they couldn't control. Perhaps they evolved beyond the need for material civilization entirely, developing forms of organization and consciousness that leave no physical traces. The implications extend far beyond Earth as well. If intelligence has emerged multiple times in our planet's history, it suggests that consciousness might be a more common phenomenon throughout the universe than we currently believe. This perspective could revolutionize our approach to searching for extraterrestrial intelligence and our understanding of life's potential for complexity and self-awareness. As detection techniques become more sophisticated, we might discover that Earth has been home to conscious minds far longer than we ever imagined. Each discovery would add new chapters to the story of intelligence on our planet, revealing a deep history of beings who wondered about their place in the universe, created meaning through art and ritual, and struggled with the same fundamental questions that occupy us today. The quest to uncover these lost civilizations represents more than historical curiosity. It's an attempt to understand the full spectrum of possibilities for intelligent life, the heights consciousness can reach, and the challenges that inevitably accompany complex organization. It's a search for wisdom accumulated across vast spans of time, knowledge that might prove crucial for our own species' long-term survival. This perspective transforms every anomaly in the geological record into a potential clue. Every unexplained pattern in ancient climate data becomes worth investigating. Every mystery in the archaeological record might hold fragments of a story we never suspected existed. The Earth itself becomes a vast library, its rocks and sediments containing chapters of a book we're only beginning to learn how to read. The civilization we're searching for might have achieved forms of advancement that seem impossible to us today. They might have developed technologies based on principles we haven't discovered, created social structures that automatically adapted to changing conditions, or maintained knowledge systems that could preserve essential information across geological timescales. They might have understood aspects of consciousness, time, and existence that we're still struggling to comprehend. Their disappearance might hold lessons about the nature of permanence and change, teaching us about the cycles that govern all complex systems, including our own civilization. Finding evidence of their existence would prove that the experiment of consciousness has been attempted before, with results we're only beginning to understand. It would suggest that intelligence represents not an accident, but a recurring miracle in the story of life itself, appearing whenever conditions allow and contributing its own unique voice to the ongoing conversation between mind and cosmos. This realization would change everything about how we see ourselves, our achievements, and our responsibilities to future generations. We would understand that we're not the first to face the challenges of building lasting civilization in an ever-changing world, and we might not be the last. We would be participants in a dialogue that spans geological ages, each generation of conscious beings adding its perspective to questions that have been asked for hundreds of thousands of years. The evidence we seek might be subtle, scattered across continents and buried beneath layers of time, but the implications of finding it would be profound beyond measure, reshaping our understanding of intelligence, consciousness, and our place in the grand sweep of planetary history. It would remind us that the story of mind on Earth is far richer and more complex than we ever dared imagine, and that our own chapter in that story is both precious and temporary, meaningful in itself, but also part of something infinitely larger. In pursuing this extraordinary possibility, we must confront one of the most challenging aspects of the entire endeavor. How do we distinguish between what we want to find and what actually exists? The human mind has a remarkable capacity for pattern recognition, but this same ability can lead us to see meaningful connections where none exist. This tendency becomes particularly pronounced when we're searching for evidence that would validate our most profound hopes about human potential and cosmic significance. The desire to discover that we're part of a longer story of intelligence can influence how we interpret ambiguous data. A strangely regular rock formation might seem artificial when viewed through hopeful eyes, even if geological processes provide a simpler explanation. Scientific methodology exists precisely to counteract these biases, but the challenge becomes exponentially more difficult when dealing with evidence from such remote time periods. The normal tools of verification become nearly impossible to apply. We cannot perform controlled experiments on events that occurred hundreds of thousands of years ago. We cannot observe the processes that created the patterns we're investigating. Instead, we must rely on inference, statistical analysis, and the careful accumulation of circumstantial evidence. This approach has served science well in many contexts, from understanding stellar evolution to reconstructing ancient climates. But it requires extraordinary discipline to maintain objectivity when the implications of our findings could revolutionize human self-understanding. The scientific community would approach any claims of ancient civilization with intense scrutiny. Peer review would be more rigorous than for almost any other type of research. Independent verification would be essential. Alternative explanations would need to be exhaustively explored and systematically eliminated. This process might take decades to complete. Initial findings would generate controversy and debate. Critics would propose natural mechanisms to explain apparent anomalies. Supporters would argue for the coherence of multiple lines of evidence. The scientific literature would fill with papers arguing various interpretations of the same data. But suppose the evidence continued to accumulate despite this scrutiny? Imagine multiple research teams using different methodologies, consistently finding patterns that point toward large-scale prehistoric human activity. Chemical signatures that correlate across geological formations. Isotope ratios that suggest controlled processes. Landscape modifications that bear the subtle hallmarks of intelligent design. The moment of scientific consensus might arrive not through any single dramatic discovery, but through the gradual recognition that natural explanations have been exhausted. The accumulated weight of evidence would eventually reach a threshold where the artificial hypothesis becomes more plausible than purely geological alternatives. This shift in scientific understanding would trigger cascading changes across multiple disciplines. Archaeology would need to develop entirely new theoretical frameworks. Anthropology would have to reconsider fundamental assumptions about human development. Even fields like ecology and evolutionary biology might need revision if evidence suggested prehistoric human management of natural systems. The educational implications alone would be staggering. Textbooks would require complete rewriting. Museum exhibits would need fundamental restructuring. The basic narrative of human history taught to children around the world would undergo revolutionary transformation. But beyond these academic adjustments lies a deeper challenge. How would modern civilization psychologically adapt to learning that we're not unique in our achievements? How would cultures built around narratives of human exceptionalism respond to evidence of previous sophistication? Some might find the revelation liberating, seeing it as proof that intelligence represents a recurring miracle rather than an isolated accident. The knowledge that consciousness has emerged multiple times might provide comfort about our own species' ultimate significance in the cosmic story. Others might experience it as profoundly disorienting. Religious worldviews would need to accommodate vastly expanded timelines for human-like intelligence. Secular philosophies, based on progressive development, would require fundamental revision. The very concept of modernity would lose much of its meaning. Political implications could be equally complex. If previous civilizations achieved sophisticated organization without our forms of governance, it might challenge assumptions about optimal social structures. If they maintained stability across vast time periods, it could inspire new approaches to long-term planning and institutional design. Economic theories might also face scrutiny. A civilization that persisted for hundreds of thousands of years would necessarily have developed sustainable resource management strategies. Their approaches might offer alternatives to growth-based economic models that assume infinite expansion on a finite planet. The technological implications present perhaps the most intriguing possibilities. If ancient peoples achieved advancement through different pathways than our own, studying their methods might reveal entirely new approaches to solving contemporary problems. Their solutions would have been tested across time scales that dwarf our own technological experience. They might have developed biological technologies that work with natural systems rather than against them. Their understanding of material science might have focused on durability and recyclability, rather than rapid production and planned obsolescence. Their energy systems might have been designed to operate indefinitely, without depleting natural resources. These alternative technological paradigms could provide crucial insights for addressing current global challenges. Climate change, biodiversity loss, and resource depletion all require solutions that can function over geological timescales. Learning from civilizations that actually achieved such longevity might be essential for our own survival. The social technologies of ancient civilizations could be equally valuable. Maintaining large-scale organization without modern communication systems would require sophisticated approaches to governance, conflict resolution, and knowledge transmission. Their methods might offer alternatives to contemporary institutions that seem increasingly inadequate for managing global-scale challenges. Imagine decision-making processes designed to consider consequences over thousands of years, rather than electoral cycles. Picture social structures that automatically adapt to changing environmental conditions while maintaining essential cultural continuity. Consider knowledge preservation systems that can maintain crucial information through civilizational disruptions. These possibilities highlight one of the most profound implications of discovering ancient civilization. It would demonstrate that human intelligence has always been capable of remarkable achievements. The difference between us and our predecessors might not be cognitive ability, but simply the specific challenges each era presents and the accumulated knowledge available to address them. This realization could fundamentally change how we approach contemporary problems. Instead of assuming that current difficulties require unprecedented solutions, we might look for principles and strategies that have proven effective across vast spans of time. Ancient wisdom might not be primitive, but rather time-tested in ways our recent innovations cannot claim to be. The search itself is already beginning to transform how we study the deep past. New analytical techniques are being developed specifically to detect subtle signs of human activity across geological timescales. Interdisciplinary collaboration between archaeologists, geologists, climate scientists, and other specialists is creating unprecedented opportunities for discovery. Satellite imagery is revealing landscape patterns that might represent ancient modifications. Chemical analysis of sediment cores is identifying anomalies that don't match purely natural processes. Computer modeling is helping researchers understand how different types of evidence might degrade over hundreds of thousands of years. These methodological advances have applications far beyond archaeology. The techniques being developed to search for ancient civilizations could help us understand climate change, predict geological hazards, and even search for signs of life on other planets. The quest to understand our own deep past is simultaneously expanding our capabilities for exploring the broader universe. The implications extend to our understanding of intelligence itself. If consciousness has emerged multiple times throughout Earth's history, it suggests that awareness and creativity represent fundamental features of natural development rather than unlikely accidents. This perspective could revolutionize fields from artificial intelligence to astrobiology. We might discover that intelligence follows predictable patterns in its development and expression. Certain organizational structures might emerge consistently whenever conscious beings attempt to build complex societies. Specific technological pathways might represent optimal solutions to universal challenges faced by all intelligent species. These patterns could provide crucial guidance for our own future development. Understanding the common features of successful civilizations might help us avoid pitfalls that have led to previous collapses. Learning about the conditions that foster long-term stability could inform our efforts to build sustainable institutions. The cosmic perspective becomes equally transformed. If Earth has been home to multiple experiments in consciousness and civilization, it suggests that intelligence might be far more common throughout the universe than current estimates assume. Planets capable of supporting life might regularly give rise to complex, self-aware beings who wonder about their place in existence. This possibility could revolutionize our approach to searching for extraterrestrial intelligence. Instead of looking only for technological signatures similar to our own, we might need to consider radically different forms of advancement. Alien civilizations might have pursued developmental pathways that leave traces we wouldn't recognize as artificial. They might have achieved sophistication through biological rather than mechanical technologies. Their communications might operate on principles we haven't discovered. Their social structures might be so different from our own that we wouldn't identify them as organized intelligence, even if we encountered direct evidence. The humbling effect of these realizations extends beyond academic disciplines into the realm of personal meaning and purpose. Learning that we're part of a much longer story of consciousness on Earth would require fundamental adjustments to how we understand our own significance. Individual lives would remain meaningful in immediate terms, but they would also take on significance as contributions to a dialogue between minds separated by vast expanses of time. Our achievements would matter not only for their effects on contemporary society, but also as additions to an ongoing conversation about what it means to be conscious in an apparently unconscious universe. This temporal connection might provide comfort for those troubled by the brevity of human existence. Death would remain final for individuals, but consciousness itself would be revealed as a recurring phenomenon, appearing again and again in new forms throughout Earth's history. Each person's contribution to understanding, creativity, and compassion would become part of a legacy extending far beyond any single lifetime. The responsibility implied by this perspective would be enormous. If we're the current custodians of intelligence on Earth, our choices about how to develop and apply our capabilities take on cosmic significance. The knowledge we preserve, the institutions we build, and the values we embody might influence how consciousness evolves for generations yet to come. This responsibility extends to our relationship with the planet itself. If Earth has been home to intelligence for hundreds of thousands of years longer than we previously believed, our role as environmental stewards becomes even more crucial. We would be responsible not only for preserving conditions that allow our own civilization to continue, but also for maintaining the planetary systems that have repeatedly given rise to consciousness throughout geological history. The search for ancient civilizations thus becomes more than an academic exercise. It represents an attempt to understand our place in the deepest story we can imagine, the evolution of mind itself on our planet. Every piece of evidence we uncover adds to our understanding of what intelligence can achieve and what challenges it must overcome to persist across the vast scales of geological time. As we develop better techniques for detecting these subtle traces, we move closer to answering some of humanity's most profound questions. Are we alone in the history of consciousness on Earth? Have others before us wondered about the same mysteries that occupy our thoughts today? What can their experiences teach us about the possibilities and limitations of intelligent life? The answers we discover will shape not only our understanding of the past, but also our vision for the future. They will influence how we approach the challenges of building sustainable civilization, how we prepare for the long-term survival of human culture, and how we understand our responsibilities to future generations who might someday search for traces of our own existence in layers of rock and sediment. The quest continues, driven by curiosity about our origins and hope that we might learn from the experiences of those who came before us. Each anomaly investigated, each unusual pattern analyzed, each interdisciplinary collaboration pursued, brings us closer to understanding whether consciousness represents a unique accident or a recurring miracle in the story of our planet. In this search, we confront the deepest questions about intelligence, time, and meaning. We grapple with the possibility that the story of mind on Earth is far richer and more complex than we ever imagined. And we face the humbling recognition that our own chapter in that story, however significant it seems to us, represents just one contribution to a conversation that may have been continuing for hundreds of thousands of years. The evidence we seek might be subtle, scattered across continents and buried beneath layers of geological time, but the implications of finding it would transform everything we think we know about ourselves, our achievements, and our place in the grand narrative of consciousness on Earth. It would remind us that the capacity for wonder, creativity, and the drive to understand might be among the most ancient and enduring features of life on our planet, appearing again and again whenever conditions allow, each time bringing new perspectives to eternal questions about existence, meaning, and our place in the cosmos. The discovery would force us to confront fundamental questions about the nature of knowledge itself. If sophisticated understanding has been developed and lost multiple times throughout our planet's history, what does this tell us about the permanence of human achievement? Our greatest scientific breakthroughs, our most profound philosophical insights, our most beautiful artistic creations might not represent unique moments of discovery, but rather rediscoveries of truths that have been grasped before. This possibility carries both melancholy and wonder. There's something deeply sobering about imagining libraries of knowledge that have vanished completely, mathematical theorems proven and forgotten, artistic traditions that flourished for millennia before disappearing without a trace. Yet there's also something profoundly hopeful about the idea that human curiosity and creativity have been expressing themselves for far longer than we ever suspected. Consider what this means for our approach to learning and discovery. We tend to think of scientific progress as cumulative, each generation building upon the work of those who came before. But what if crucial insights have been lost? What if we're not advancing toward unprecedented understanding, but rather slowly reconstructing wisdom that once existed in more complete forms? This perspective might explain some of the most puzzling aspects of human intellectual history. Why do certain mathematical relationships appear independently in widely separated cultures? Why do we find similar architectural principles emerging simultaneously across the globe? Why do mythologies from different continents share remarkably consistent themes and structures? Perhaps these aren't coincidences or examples of convergent thinking. Perhaps they represent fragments of much older knowledge systems, pieces of a larger understanding that has been scattered and partially preserved through cultural transmission across vast spans of time. The golden ratio, the significance of certain astronomical alignments, the recurring appearance of specific geometric forms in art and architecture might all be echoes of more complete systems of knowledge. The implications become even more intriguing when we consider the possibility of intentional knowledge preservation. An advanced ancient civilization would have understood the fragility of information across geological timescales. They might have developed methods for encoding essential insights in forms designed to survive cultural disruption and environmental catastrophe. These encoding methods might be far more sophisticated than anything we've imagined. Instead of relying solely on written records or physical artifacts, they might have embedded crucial knowledge in landscape modifications, genetic patterns in domesticated species, or even the cultural practices and oral traditions of successor populations. Imagine mathematical concepts encoded in the proportions of ancient earthworks, astronomical knowledge preserved in the breeding patterns of certain animals, or philosophical insights transmitted through ritualistic behaviors that persist long after their original meaning has been forgotten. The very survival strategies that allowed information to persist across hundreds of thousands of years might make it nearly invisible to our current methods of detection. This possibility transforms how we might search for evidence of ancient civilization. Instead of looking only for obvious artifacts or chemical signatures, we might need to examine patterns in human culture itself. Are there mathematical constants, architectural principles, or symbolic systems that appear too consistently across different societies to represent independent discoveries? The search becomes a detective story, spanning not just geography and geology, but the entire development of human thought and expression. Every persistent cultural pattern becomes a potential clue. Every unexplained consistency in human behavior across different civilizations might represent inherited knowledge from sources we've never suspected. But the most profound implications might lie in how such a discovery would change our understanding of human potential itself. We've grown comfortable with the idea that our cognitive abilities represent the pinnacle of intelligence on Earth. We assume that previous humans were necessarily less capable than we are, limited by their lack of accumulated knowledge and technological tools. Finding evidence of sophisticated ancient civilization would shatter these assumptions. It would demonstrate that human intelligence has always been essentially what it is today, capable of remarkable achievements regardless of the specific historical context. The difference between us and our ancient predecessors wouldn't be mental capacity, but simply the particular challenges each era presents and the specific knowledge available to address them. This realization would have revolutionary implications for education, psychology, and our understanding of human development. If ancient peoples were capable of achievements we can barely imagine, what untapped potential exists in every human mind today? How many forms of intelligence and creativity have we overlooked because they don't fit our current technological paradigms? The discovery might reveal that we've been dramatically underestimating human capability. Instead of seeing ourselves as the first generation to achieve true sophistication, we might learn that we're simply the latest in a long series of experiments in consciousness and organization, each bringing unique perspectives to eternal challenges. This perspective could transform how we approach contemporary problems. Instead of assuming that current difficulties require unprecedented solutions, we might seek principles and strategies that have proven effective across vast spans of time. Ancient approaches to sustainability, social organization, and knowledge preservation might offer tested alternatives to methods that have only been tried for decades or centuries. The environmental implications alone could be transformative. A civilization that thrived for hundreds of thousands of years would necessarily have achieved something we're desperately seeking today: true long-term sustainability. Their technologies would have been designed to work with natural cycles rather than against them. Their resource management strategies would have been tested across multiple climate shifts and environmental changes. Understanding their approaches might provide crucial insights for addressing climate change, biodiversity loss, and resource depletion. How did they maintain large populations without degrading their environment? How did they adapt to dramatic climate shifts without losing social cohesion? How did they balance innovation with conservation across geological timescales? The social implications would be equally profound. Maintaining complex organization across hundreds of thousands of years would require institutional designs we can barely conceive of today. Their governance structures would need to function effectively across thousands of generations. Their educational systems would need to preserve essential knowledge through disruptions that would challenge any society. These achievements might seem impossible from our current perspective, but they would represent the minimum requirements for any civilization that actually persisted across such vast time periods. Understanding their methods might revolutionize how we approach long-term planning, institutional design, and social organization. The psychological impact on modern humanity would be immense and complex. Learning that we're not the first to achieve sophisticated civilization would humble our sense of uniqueness, but it might also provide profound comfort. If consciousness has emerged multiple times throughout Earth's history, it suggests that awareness and creativity represent fundamental features of natural development rather than unlikely accidents. This perspective might offer new forms of meaning and purpose. Individual lives would remain significant in immediate terms, but they would also take on importance as contributions to a conversation between minds separated by vast expanses of time. Our achievements would matter not only for their contemporary effects, but as additions to an ongoing dialogue about consciousness, creativity, and the search for understanding. The responsibility implied by this perspective would be enormous. If we're the current custodians of intelligence on Earth, our choices about how to develop and apply our capabilities take on cosmic significance. The knowledge we preserve, the values we embody, and the institutions we create might influence how consciousness evolves for millennia to come. This responsibility extends to our relationship with the planet itself. If Earth has been home to intelligence for hundreds of thousands of years longer than we previously believed, our role as environmental stewards becomes even more crucial. We would be responsible not only for maintaining conditions that allow our own civilization to continue, but also for preserving the planetary systems that have repeatedly given rise to consciousness throughout geological history. The technological implications present some of the most fascinating possibilities. If ancient peoples achieved advancement through pathways different from our own, studying their approaches might reveal entirely new solutions to contemporary challenges. Their methods would have been tested across timescales that dwarf our own technological experience. They might have developed what we could call deep technologies, systems designed to function effectively for hundreds of thousands of years rather than decades or centuries. Their approaches to energy, materials, and information processing might have prioritized longevity and sustainability over rapid development and planned obsolescence. These alternative technological paradigms could provide crucial guidance for building truly sustainable industrial systems. How do you create manufacturing processes that can continue for geological timescales? How do you design energy systems that don't exhaust their resource base? How do you build information storage systems that remain accessible across cultural disruptions? The answers to these questions might be encoded in the very landscape around us. Ancient technological systems might have left subtle signatures that we're only beginning to learn how to detect. Unusual mineral concentrations could represent the remains of sophisticated materials processing. Landscape modifications might reflect engineering projects designed to function across vast time periods. The search for these signatures requires us to think about technology in fundamentally different ways. Instead of looking for devices and machines, we might need to search for systems and processes. Instead of expecting obvious artifacts, we might need to detect subtle patterns that reveal intelligent design, operating across scales we've never considered. This expanded definition of technology could revolutionize our understanding of what advancement means. A civilization that achieved true sustainability might have developed forms of sophistication that seem primitive to us, but actually represent solutions to problems we haven't learned to solve. Their apparent simplicity might conceal profound understanding of natural systems and long-term thinking. The cosmic perspective becomes equally transformed by these possibilities. If Earth has been home to multiple experiments in consciousness and civilization, it suggests that intelligence might be far more common throughout the universe than our current estimates assume. Planets capable of supporting life might regularly give rise to complex, self-aware beings who wonder about their place in existence. The possibility of discovering a 450,000-year-old civilization remains tantalizingly within reach of modern science. While we may never find definitive proof, the search itself transforms how we understand intelligence, time, and our place in Earth's vast story. Whether consciousness has emerged once or many times, our responsibility remains the same: to preserve the miracle of awareness for whatever minds may follow, adding our voice to a conversation that spans geological